Everybody, so I'm going to do a review of the review sheet. So question number 1 is represented in the diagram below. An object of mass m located on the surface of the moon is attracted to the moon with gravitational force F. Basically, we're looking at this. The force of gravity is equal to the universal gravitational constant, mass 1, mass 2, over r squared, found in your reference table. Now, here, m, which you can see here on the moon, it's hard to point out, it's on the bottom side of the moon. It's just one plain old m. So one of these masses is the mass of the moon. So this is the moon. The other mass is the mass that they're describing, whatever this object is, the mystery mass, which is just 1m. And it's a radius. It's on the surface. It's 1 radius from the moon. So if here's the moon and here's the mass, it's 1m, and it's found 1 radius from the center of the moon. Now the second part of the question. An object of mass 2m at an altitude equal to the moon's radius r above the surface of the moon is attracted to the moon with a gravitational force of what? So here's a 2m mass over here. And notice it's 1 radius above the moon's surface, which means it's a whole 2 radiuses from the center of the moon. If you plug in these values into the equation, you'll see that the force of gravity is equal to the universal gravitational constant, m1, which we defined as the moon in this case. Doesn't really matter if it's the first or second, we just pick one. And m2, this mass in orbit, is 2m. So since it's twice the mass, it's going to be twice the force. But now don't forget about the radius underneath. Now this radius here is also twice as far away from the center of the moon, and it's also being squared. So if you distribute the square right, you're going to end up getting 4r squared, which means you can divide this thing by 4 in the denominator. Now 2/4 is the same thing as saying 1/2 the original force of gravity that this mass was experiencing, or half a force. The answer for 1 is C. 2. What is the magnitude of the gravitational force of attraction between a 0.425 kilogram soccer balls when the distance between their centers is 0.5 meters? So here we're going to look at the force of gravity is equal to the universal gravitational constant times mass 1 times mass 2 over r squared. Now, since these masses are the same, we're going to basically do the universal gravitational constant, 6.67 times 10 to the negative 11 newtons times meters squared over kg squared, found in your reference table, times m1 times m2, or 0.25 kg, should say 425 kg. I'm going to square this guy because 2 of these soccer balls, 1 soccer ball times another soccer ball is soccer ball squared, divided by the radius squared, 0.5 meters squared. If you do this in a calculator, let me pull up a calculator quickly. Here we go. So 6.67 e to the negative 11 times 0.425 squared divided by 0.5 squared equals 4.819 times 10 to the negative 11. 4.819 times 10 to the negative 11 newtons. That is answer choice B on the answer table. Alright, number 3 now. So 3 reads, the Hubble telescope is in orbit 5.6 times 10 to the 5 meters above the Earth's surface. The telescope has a mass of 1.1 times 10 to the 4 kilograms. Earth exerts a gravitational force of 9.1 times 10 to the 4 newtons on the telescope. The magnitude of the Earth's gravitational field strength is located at this location is. Here it's useful to take a quick look at your reference table. Your reference table makes a note that the strength of the gravitational field is represented by G. G is acceleration due to gravity, or the gravitational field strength. So if you want to find the gravitational field strength, you can use this equation. G is equal to the force of gravity divided by mass. So if we go back to this question for number 3, the force of gravity is equal to 9.1 times 10 to the 4 newtons. The mass is equal to 1.1 times 10 to the 4 kg. So the gravitational field strength is equal to force of gravity divided by the mass, or 9.1 times 10 to the 4 newtons divided by 1.1 times 10 to the 4 kg. The 10 to the 4's cancel out. 9.1 divided by 1.1 equals 8.27, repeating, newtons per kilogram, the gravitational field strength. That is choice C for number 3. Moving on, question 4. The diagram below represents a 2 kilogram toy car moving at a constant speed of 3.33 meters per second clockwise in a circular path with a radius of 2 meters. At the instant of the diagram, the centripetal force acting on the car is what? So centripetal force is equal to the force of the centripetal acceleration divided by mass. Oh, sorry. This equation is correct. Centripetal acceleration times mass. And centripetal acceleration is equal to velocity squared over the radius. Now, all of this can be found on the reference table. So here is centripetal force and centripetal acceleration found on the reference table. Those equations. So what we can do is just substitute in centripetal acceleration. So the force centripetal is equal to v squared over r times mass. And you will get the velocity of 3 meters per second squared divided by the radius of, by the way, it does say here 2 meters, great. 2 meters times the mass, which is 2 kilograms. The 2's cancel out. 3 squared is 9 newtons. The answer here is, we need a direction. So the toy car is over here. That is the toy car. And centripetal force and centripetal acceleration are always pointing to the center of the circle. And also, the velocity is always tangent that circle. That's a very bold line. There we go. So the velocity is tangent that circle. So we're asking about, we want to know where the centripetal force is going. So the centripetal force is going north, north-south, northeast, but instead west, right? Because it's going to the center, to the left. As you can see here, left, from its current position, with a force of 9 newtons. 9 newtons west. The answer is D. Okay, now let's look at number 5. An object moving with a constant speed in a circle is in a circular path. The object's centripetal acceleration remains constant in, the answer is A, magnitude only, because if you consider what we just saw earlier with a circular path, if I am positioned in various points, let's say I'm moving around in a circle in this general direction, right? Let's say I want to go this way, and then this way, right? And this way, that's how I'm spinning. My centripetal force is always pointed towards the center. My acceleration is always pointing towards the center. And if nothing else is changing, then if I'm spinning at a constant velocity, if these arrows are essentially going to be the same in size only, you can see here it's pointing west, here it's pointing southwest, here it's just pointing straight up south or down, here it's pointing kind of down to the right. The direction constantly changes. Direction changes. However, the magnitude, or the size of the arrow, magnitude slash or parentheses size of arrow or vector stays the same. So the answer is A, magnitude only. Let's look at number 6. A body B is moving at a constant speed in a horizontal circular path around point P, which diagram shows the direction of velocity, which is tangent, remember, and the direction of a centripetal force acting on the body, which is always pointing towards the center. So remember, that was a terrible circle. Oh, come on, computer. No, you don't want to read my circles. There we go. So if I'm moving, let's say, counterclockwise, because I like going counterclockwise, my velocity is tangent. Going tangent. And my force and acceleration are always pointing towards the center. So force and acceleration are pointing towards the center, and my velocity is tangent. Now in this case, C is a nice clear fit because C shows you it did not work out nearly as well as I hoped. C shows you a tangent velocity, a velocity that's tangent, pointing down. This in a different color. The velocity is pointing down. It's tangent, while the centripetal force and the acceleration are pointing towards the center. The answer is C. Let's take a look at 7. So 7. A child pulls a wagon at a constant velocity along a level sidewalk. The child does this by applying 22 Newton force along to the wagon handle, which is inclined at 35 degrees, to the sidewalk as shown. What's magnitude of the force friction on the wagon? So keywords here. This thing is going at a constant velocity. So if you're at a constant velocity, number 7, constant velocity means a lot of things. And one of the things it means that's real key is F net is 0. All the arrows cancel. All of the forces that are in the diagram cancel out. So if you have a wagon, it's being pulled with 22 newtons at a 35-degree angle. Some of that is going along the x-axis, the force x. Some of that is going along the y-axis, the force of y. Right? Because it's at an angle. Some of it's up, some of it's sideways. You're not pulling straight up. You're not pulling completely sideways. You're pulling somewhere in apologies. You're pulling somewhere in between. Now, the force of gravity will cancel out the force of the pull up, and whatever is left would be the force normal. So these y forces get canceled out. We can kind of ignore it. It doesn't really matter. What we are interested in is these x forces, because the force x gets canceled out. And the only force to counteract this pull to the right on the x-axis is the force friction resisting that movement. And the force friction is basically equal to the force x. The magnitudes, at least. Since they're in opposite directions, we can say the negative of force friction is equal to the force x. Now, how do you find force x? Your reference table shows you how to get those x vectors. You should have this memorized at this point, but if you don't, just don't forget, it is on your reference table. Any vector along the x-axis is equal to the vector times cos theta. So ax is equal to the vector a cos theta. So f of x is equal to the force of 22 newtons times the cosine of 35 degrees. Now, when you're going to calculate this on your calculator, keep in mind that you should be in degrees if you are not, because you're going to get some funny looking answers. 22 times cos of 35 gives us 18 newtons along the x. And if you're pulling with 18 newtons along the x, that means the force friction, to cancel it out completely, is resisting with 18 newtons in the opposite direction. So your friction is 18 newtons left, or choice C. The magnitude of friction is 18 newtons, C. Number 8. 1,000 kilogram car travels at a constant speed of 20 meters per second on a horizontal circular track. The diameter, key word here, always helpful to draw. So let's see what's going on with number 8. The diameter, which is a line that goes from edge of the circle through the center to the other edge of the circle. This thing is 1 times 10 to the 2 meters, or aka 100 meters. That's the diameter. And what's the centripetal acceleration? So centripetal acceleration is equal to the velocity squared over the radius, right? And we know that the velocity, this car is moving with a speed of 20 meters per second. The velocity is 20 meters per second. So just substituting these values. AC is equal to 20 meters per second over the radius. Keyword, the radius. Now 100 meters is the diameter. The radius is essentially half of that. 50 meters. Keyword, radius. 50 meters. And don't forget to square the velocity, because I almost did. 20 squared is 400 meters squared per second squared, because everything got squared, over 50. Whoa, why is that triangle? Yikes. 50 meters. The square is going to cancel out the meters in the denominator, and you're left with 400 divided by 50, 8 meters per second squared. The answer here should be C, 8 meters per second squared. Next up, number 9. So 9 reads, which diagram represents the direction and velocity of acceleration of a toy car as it moves clockwise horizontal circular path at a constant speed? Refer to our work for, was it question 6, I think? Question 6 and question 9 are essentially the same. So acceleration is pointing towards the middle, velocity is tangent. Your answer is A. B shows a tangent acceleration. No, that's wrong. C shows a tangent acceleration. Still wrong. Velocities are in opposite direction, but acceleration is the key giveaway there. And D shows tangent velocity. Good, but the acceleration is pointing out. Acceleration should always be pointing towards the middle. Answer has to be A. The only one that makes any sense. Moving on to 10. I'll write down here. C number 6. 10. The diagram below represents a box sliding down an inclined plane at a constant velocity. And then it shows which arrow represents the direction of the frictional force acting on the box. So if you have an inclined plane, right? Sure. And there's a box on it. Force is going to resist the movement. So gravity is going to go straight down. So frictional force is going to resist the movement of the sliding box. And the force of gravity is going to try to get this thing to slide down the box. This is called, if you cannot recall, the force of gravity parallel, because it is parallel the incline. Now, force of gravity is going to try to get this thing to slide. Friction resists that movement, so friction goes the opposite direction. Force friction. And that arrow going up the incline is D. The answer here is D. 11. A box weighing 46 newtons rests on an incline that makes an angle of 25 degrees with the horizontal. What's the magnitude of the component's box? The component of the box is weighed perpendicular to the incline. So here you go. This angle is going to be 25 degrees. We have a 46 newton box. And now what that means is the weight of this thing going down, that is 46 newtons. That's the weight, or aka the force of gravity. And a reminder, these things are hard to remember, it's labeled for you in your reference table. Force of gravity is equal to weight. Fg equals weight. So, If you want to find the force perpendicular is how much of gravity is pushing up against that incline, because it wants to fall down and it would want to fall through that ramp, but it can't. The ramp's actually going to push back up, right? So that's going to be the force, the normal force, which is kind of a tangent of what we're talking about right now. This is not like super relevant to answering this question, but like is important to inclined planes and understanding how these things operate. But anyway, force of gravity perpendicular is perpendicular to that inclined plane. And to find that, you use this equation, the force of gravity times cos theta. If you plug in these numbers, the force of gravity perpendicular is equal to 46 newtons times the cosine of the angle 25 degrees. And that will give you a force of gravity perpendicular of, let's go to our handy dandy calculator, 46 times cos 25, 41.7 newtons. Or C, if you're on it to 42 newtons. 11 is C. Let's do number 12. When you sum all the forces acting on the block on an inclined plane when the sum of all the forces acting on the block on the inclined plane is 0, the block must be what? So remember we mentioned earlier, if we scroll up to our earlier work, constant velocity means the F net equals 0 newtons. That is key to this question 12. When you add everything up, when you take the F net, which means you take all those arrows and you add them all up, and they all cancel out, and everything comes to 0, everything is balanced. The perpendicular forces in both directions are equal and cancel. The parallel forces in both directions are equal and cancel. Everything cancels. That means the object could be at rest, sure. Must be accelerating is absolutely incorrect, because if it's accelerating, that means that there's an unbalanced force. F net cannot equal 0 if things are accelerating. So can't be B. Maybe slowing down? No, because that means it's decelerating. Choice C basically says you have a negative acceleration, you're decelerating, which doesn't work out either. Now the correct answer is maybe moving at a constant speed, D. Because if you're moving at a constant speed, as we saw earlier when I showed you where this information was written down, constant speed equals the F net of 0 newtons. There's no acceleration if you're at a constant speed. Hey, maybe you're at a constant speed of 0. That's a constant speed. Just means you're not accelerating or decelerating. And also be wary of absolutes. If you see must be, doesn't mean it's not wrong, but you should be a little hesitant. If you see maybe is a pretty vague term. It means this could be a situation where the answer is correct, and like since there's a lot of wiggle room in that answer, you should consider that as a strong and likely candidate. But 12 is the obvious. For number 12, D is the obvious answer. Constant speed means no unbalanced forces, no acceleration. The F net is 0. Let's do number 13. 13. An 8 Newton block is accelerating down a frictionless ramp inclined at 15 degrees to the horizontal as shown in the diagram. Which magnitude of the net force caused the block to accelerate? So for number 13, keep in mind this thing is frictionless. So if you're going to draw all of our forces, which you can do quickly, you really should know all these at this point, but I will summarize in case you need the review. So here's the F of gravity, force of gravity, which was terribly drawn. And that force of gravity can be broken up into its components along the perpendicular axis, the force of gravity is perpendicular, and parallel the inclined plane, the force of gravity parallel. And notice I drew these things because you can take these guys, and I'm going to try my best to do that. You can take these and essentially bring them over, and notice they make a right triangle. What? Amazing. But yeah, these are the components of gravity, different directions. Force normal tries to counteract the force of gravity perpendicular. So essentially along the perpendicular axis, these two cancel out. Normally you'd have friction, but notice the key word here. What? That's not right. Normally you have friction, but notice the key word here, frictionless. Frictionless. Since this thing is frictionless, there is no friction, so undo all of that. The only unbalanced force that's not canceled out is the force of gravity parallel. Now, that means this is the only force left over. F net is equal to the force of gravity parallel, because it's what's left after everything is added up and canceled out. And the force of gravity parallel is equal to the force of gravity times the sine of theta. Now, the force of gravity was given to you. It's the weight of the box, 8 newtons, times sine the incline of the ramp, 15 degrees, will get you your F net. 8 times sine of 15 is 2. F net is 2 newtons. The answer is B, 2.1 newtons. All right, that's how you do 13. Let's do 14. Now 14 reads, 5 kilogram box is sliding across a level floor. The box is acted upon by a force of 27 newtons east and a frictional force of 17 newtons west. What's the magnitude of the acceleration of the box? So level floor, which means things are flat. Nice. 5 kilogram box. Simple. The box is sliding on the floor. It's acted upon by 27 newtons east. So 27 newtons east. And a frictional force of 17 newtons west. 17 newtons west. Great. What's the magnitude of the acceleration? So acceleration is equal to F net over mass. Now you can think of gravity if you want and the normal force if you want, but these things just cancel out. You don't really have to consider them in any equations. You want to find F net. Again, this is on your reference table if you don't know the formula for acceleration. Acceleration is equal to F net over mass. It's up here. Now, F net is the sum of forces. So take the forces and add them up. Again, these y forces cancel out. We don't really need to pay much attention to them. These forces along the x-axis are kind of important. So let's say to the right is positive. So let's get the acceleration is equal to the sum of forces, the F net over here. Let's take 27 newtons, and let's say this one's positive because it's going to the right, and I feel like saying right is positive. And let's add that with negative 17 newtons. What? And I made it negative because it's going to the left. And since I called right positive, I have to say the left is negative. That's going to give us the force net, divided by the mass, 5 kg. Now if you do 27 minus 17, you'll get an answer of 10 newtons. And if you divide that with 5 kg, you'll get an acceleration of 2 meters per second squared. The answer is B, 2 meters per second squared. 15. A student is standing in an elevator that travels from the first floor to the 10th floor of the building. The student exerts the greatest force on the elevator when the elevator is what? So again, think of your free body diagrams. So here's someone in an elevator. They're hanging out, playing around in the elevator. Now, gravity is going to be always going down. And gravity is pretty much constant because it's the mass, which we're not really changing, times the acceleration of gravity, which doesn't really change near the Earth's surface. So there you go. This doesn't change. This arrow going down does not. But we are going to play with this arrow going up. So that arrow going up is the normal force. It's the force of that elevator pushing back up. Now, if they're equal to each other, which I don't know if I did that correctly, but I'll try. Yeah, they look equal now. If they're equal to each other, everything cancels out and nothing is accelerating. You might be moving up or down, but you're not accelerating. So you don't feel heavier or lighter. The floor isn't pushing up against you any harder than what gravity would be doing. However, if you want to have the greatest force on the floor of the elevator, that means that this arrow going up is going to be pushing on this person. It's going to be pushing up harder. And if you make this arrow bigger, right, you're going to be accelerating upwards, because when you put these two arrows together, you might notice that you're going to have a leftover force that will be going up. The leftover from all of this is going to be going up about that much. Excuse me. All right, so now that we just played around with some arrows, let's consider our choices. A, accelerating upward as it leaves the first floor. That's it. That's it. You're accelerating up. That's the answer. You're moving up, accelerating up. You're going to feel heavier. B, slowing down as it approaches the 10th floor. If it's slowing down, that means it's going to be, the down arrow is going to be bigger than the up arrow. So it would look something kind of like this. Oh, I can't make it any smaller. That's a shame. It should be smaller. And if it's smaller, that means you're slowing down while you're moving up. You're essentially accelerating downwards. Think of throwing a ball up in the air. It slows down as it reaches its peak, kind of like what an elevator does as it reaches the 10th floor. It's not B. You're going to feel lighter in that case because the floors are going to be pushing up on you as hard. C, moving at a moving upward at a constant speed. Nope, because that means there is no unbalanced force. That's just like normal standing. And D, at rest on the first floor. Basically the same force as C. D and C would essentially be the same exact setup. A is the correct answer. If you accelerate up, the floor pushes up against you more and you feel heavier. You feel a greater force. The answer is A. 16. A rubber block weighing 60 newtons is resting. There we go. Is resting on a horizontal surface of dry asphalt. What's the magnitude of the minimum force needed to start the rubber block moving across the dry asphalt? So it's at rest. It said it a few times because that's a key piece of information to solve number 16. So if you haven't noticed, we were trying to find the force friction. They gave you a ton of clues, and I'll point them out. 1, you have weight. Weights can be key here. 2, dry asphalt. Man, that seems like a very specific piece of information. There's a reason they're giving it to you. And then they're saying the magnitude of the minimum force needed to get this thing started. That's because friction has a limit. Once you pass that limit, you can basically accelerate however fast. And it said to get it started, right? It said this thing is at rest. It's resting on. And to start moving. So this thing is not moving at the moment. So let's put these pieces of information together and let's find out what we really need. First off, here's the equation for friction. If you have forgotten, F of F is equal to mu times Fn. F of F is the force friction, Fn is the normal force, and mu is the coefficient of friction, which you can see here on the first page, approximate coefficients of friction. Let's look at rubber on dry asphalt. Rubber on dry asphalt is right here, and we're going to focus on the static mu. Static coefficient of friction is 0.85. Now, let's go back to our setup. The rubber block weighs 60 newtons. So again, if you have a rubber block and it weighs 60 newtons, that's the force of gravity going down. The normal force is 60 newtons going up. So F of N is 60 newtons. Now if you multiply 0.85 with 60 newtons, 0.85 times 60 newtons, you have a frictional force of, a static frictional force of 51 newtons. Your answer is C. 51 newtons. Okay, let's do 17. An 8 Newton wooden block slides down a horizontal wooden floor at a constant velocity. The coefficient of kinetic friction of wooden wood is 3.3. What is the magnitude of the force of kinetic friction between the block and the floor? Well, it's quite literally the same equation. The force of friction is equal to mu times the normal force. You have an 8 Newton wooden block, so 8 newtons, which is the force of gravity. So the normal force is going to be the same thing, 8 newtons going up, because you are on a level floor. They're all little pieces of information they give you. Horizontal wooden floor, right? So it's pretty level. There's no incline here for a reason. Now, the coefficient of friction is 0.3. The normal force is 8 newtons, and this is not one that requires a calculator. The frictional force is 2.4 newtons. A. Okay, now let's do 18. A 0.5 kilogram puck sliding on a horizontal shuffleboard court is slowed to a rest by a frictional force of 1.2 newtons. What's the coefficient of kinetic friction between the puck and the surface of the shuffleboard court? So, same equation, some different numbers now. So, you want to find mu. To get mu by itself, divide the normal force on both sides, and you'll get something like force of friction divided by the normal force will give you mu. Force of friction was provided to you. It's 1.2 newtons. And the normal force you can find by the information provided. So you have a puck that's 0.5 kilograms. Gravity is essentially going to be equal to the normal force pushing up. To find gravity, you can use this equation. The force of gravity is equal to mass times gravity. The mass is 0.5 kg. Gravity is 9.81 meters per second squared. Again, all these things are in your reference table. You can manipulate this equation here. This equation down here, where it reads gravity is equal to the force of gravity divided by mass. To get the force of gravity by itself, multiply mass on both sides, and you'll see that force of gravity is equal to mass times gravity. If you forgot what gravity is, you really should know what that is, but here it is on the reference table, 9.81 meters per second squared. So half of 9.8 meters per second gives you a force of gravity of 4.9 newtons. That means the normal force is 4.9 newtons up. That means you can do 1.2 newtons, which is the force of friction, divided by the normal force of 4.9 newtons. And that gives you a coefficient of friction of 1.2 divided by 4.9. 0.24489. So mu is equal to 2.4, sure. Oh, sorry, 0.24. I read that incorrectly. 0.24. That's it. No units for a coefficient of friction. And also, by the way, if you're not sure if there's units, check the reference table. All these things have units. But notice the coefficient of frictions do not, because there are no units for that. If I kind of move too fast, I'm just going to kind of highlight what we did first. First, you have to find the force of gravity, right? So here's the force of gravity. Found it to be 4.9 newtons. Moving on to question 19. An object weighing 2 newtons is pushed across a horizontal frictionless surface by a horizontal force of 4 newtons. The magnitude of the net force acting on the object is what? So a reminder. Oops, sorry, forgot to change the highlighter for 19. Looking for the net force. The net force is the sum of all the forces. This is actually pretty straightforward. If you're going to draw this out, there's a horizontal, flat surface, you mean. That's horizontal, just means flat. frictionless surface, so there's no friction. That's key here, because you will see shortly why. And is an object weighing 2 newtons. So that direction of the 2 newtons is 2 newtons down, because it's the force of gravity, and gravity goes down, which means the normal force is going up 2 newtons. And there's a horizontal force of 4 newtons pushing it sideways in some direction. Doesn't really say which direction. Now, if you put all these things together, you get the net force. There is no frictional force. That doesn't exist, so that's gone because there's no friction. The y values cancel out, so these are essentially gone, and you're left with the horizontal force going left, in my example, of 4 newtons. So the net force is 4 newtons. That's what's left over after you add everything up. The answer is D, 4 newtons. Okay, number 20. 220 Newton forces acting currently on the object. What angle would these forces produce the resultant with the greatest magnitude? Well, number 20 is pretty straightforward. You want to get the biggest resultant, and you have 2 forces. You have one force of 20 newtons. You have another force of 20 newtons, right? If you want to get the biggest force, put these 20 Newton forces together. And the angle is going to basically be 0 degrees. And by that I mean there is no change in angle. If you want, you could basically take these guys and really actually lay them out like at 20 degrees. Oh, it doesn't want to let me rotate them. That's okay. They're 20 degrees. If you did 45 degrees, you have 20 newtons like this, let's say flat. So, okay, just to be clear, the answer is A, 0 degrees, because they're lined up perfectly. Here's another example of 0 degrees. That's flat, 20 plus 20 gives you a 40 Newton resultant. If they're at 45 degrees, 20 and 20 at 45 would be something less than 40. You can do the math. Honestly, it's going to take a lot of time to do. For each of these choices, it's not really worth it. If you did it 90, you'd see that 20 and 20 gives you an isosceles triangle. You can do the math on this one too if you'd like. Resultant's going to be less than 40. And if you did 180, you have 20 going one way, 20 going the opposite way. They completely cancel out, and you get 0 newtons for choice D. The only one that makes any sense is A. A must be the answer. 0 degrees because they're perfectly lined up. Moving on to 21. 21 reads, a 5 Newton force and a 7 Newton force act concurrently on a point. As the angle between the forces increase from 0 to 180, the magnitude of the resultant of the two forces change from what? So if there's 0, you have a 5 Newton force and a 7 Newton force together. When you put these together, you get 12 newtons. And as you change from 0 to 180, if I took this arrow and I kind of rotated it, whoa, from 0 to 1 degree to 45, all the way to 90, and then even more, 120, 135, eventually to 180. You put them together like this, you're going to get a resultant with a slight difference. See that? That is going to be 2 newtons. So you can go from 2 newtons, which is the smallest resultant you can get. If you try to completely cancel each of these out, or the largest resultant, 12 newtons. So this is your range, 2 to 12 newtons. The answer is C. Or B, I guess. Oh, from. Yeah, it's C. Because 0 degrees will get you 12. So you started with 12 newtons at 0 degrees. 180 degrees gets you 2 newtons. You end at 2 newtons if you make it all the way to 180. So, apologies, I should consider the chronology of this, the order in which we did these. 12 to 2 newtons. 5 newtons, 7 newtons. Gives you 2 newtons. There you go. That's 21. The answer is C. 22. 5 Newton force directed east and a 5 Newton force directed north, acting concurrently on the point. The resultant of the two forces is what? So if you're going to go 5 east, and 5 north, you're going to do a squared plus b squared will give you c squared, which in this case, if you did the math, you'll get something like 7 newtons. And the direction of this thing is northeast, because you went east and you went north, so together you're going to go 7 newtons northeast. The answer is C. 23. An 80 kilogram skier on wax skis does a thing. Sorry, I'm trying to fix my zoom. Slides along a horizontal surface with a constant velocity while pushing with his poles. What's the horizontal component of the force pushing him forward? So here's a skier, right? Here they go on their skis, sliding at a horizontal slope, with no slope, I guess. They have a mass of 80 kg along with their skis, which is going to be key. You'll see why. And they gave you some key information. Waxed skis, and they're skiing on snow. So waxed skis on snow. So if you haven't picked it up yet, we're going to look for the force of friction. And here's why. So what's the horizontal component of the force pushing him forward? So here's the force pushing him forward, right? The force he's applying. Well, to get that, you need to find the force friction, because he's moving at a constant velocity. Keywords. Reminder, constant velocity. Constant velocity means that the F net is 0. So the force going forward is going to be canceled by the force going backwards. So they have to be the same. The force going backwards, the force resisting that motion, is the force of gravity, the force friction. Now, force friction is equal to mu times the normal force. The normal force is the force pushing up. That's actually going to cancel out the force pushing down by the force of gravity. And the force of gravity is equal to mass times gravity. And we know the mass to be 80 kilograms, and we know gravity to be 9.8 meters per second squared. So finally, the force of gravity is 80 times 9.8. Should be like, what, 77? I don't know how to do my math. 784 newtons is the force of gravity, which means the normal force is 784 newtons up. So we have a normal force of, I'll do it in the same color, 784 newtons. Now mu, using your reference table, wax ski on snow is 0.5. And again, he said they're sliding, so we're looking at kinetic. So mu is 0.5. If we multiply 784 with 0.5, we get 39 newtons. So the force of friction is 39 newtons, which means that the force applied is going to cancel it out, and it must also be 39 newtons. So the answer is 39 newtons, or if you round it, C, 40 newtons. 24. A box is pushed toward the right above a classroom floor. The force of friction on the box is directed what? So if you're pushing box to the right, here's a box, you're going to push to the right, the force of your push. Friction is going to resist it. It's going to go left. Friction is left. 25. A 100 kilogram cart accelerates 0.05 meters per second squared west as a horse exerts a force of 60 newtons west on the cart. What's the magnitude of the force the cart exerts on the horse? So if you push with 60 newtons, the thing is going to push back with 60 newtons. The horse exerts 60 on the cart. The cart exerts the same on the horse, 60 newtons. The answer is 25. For 25 is C, because of Newton's third law. Every action has an equal and opposite reaction. Okay. So for 25, the trick was not to get caught up in all the details and kind of understand what the question is describing. 26. Which body is in equilibrium? Equilibrium, in case you are unfamiliar with the term, equilibrium means that the F net is 0. Everything is balanced. There are no unbalanced forces. Man, I spelled equilibrium wrong. There are no unbalanced forces. Everything is balanced. Everything looks good. Everything is balanced. So, if F net is 0, that means there's no acceleration. There's a constant velocity. All right. So a satellite moving around the Earth in a circular orbit. Circular orbit for A means there's a centripetal acceleration. Can't be A. B, the cart rolling down a frictionless incline. If it's rolling down a frictionless incline, that means gravity is going to be accelerating it. The force of gravity parallel. Nope, because it's not 0. C, an apple falling freely towards the surface of the Earth. That means that there's going to be a force of gravity on the apple, right? So it can't be C. D, a block sliding at a constant velocity. D, because it's going at a constant velocity. So 26 is D. 27. The diagram shows a 100,000 Newton truck at rest on a hill at an angle of 88 degrees with the horizontal. What's the component of the truck's weight parallel to the hill? So you have a hill. It's in the diagram. Now the force of gravity parallel for number 27 is equal to the force of gravity sine theta. So the force of gravity they gave you, it's weight. The 1 times 10 to the 5 Newton truck. That's the force of gravity. Sine the angle of 8 degrees. That's going to get you a force of gravity parallel. So 10, or I could just do this. Second log 10 to the 5 times the sine of 8 degrees. That is not, oh no, it is correct. That is correct. I forgot how big 10 to the 5 was for a second. Yeah, the answer is 13,917. If we're going to round it to, what, 2 significant figures? Look at something like 1.3 times 10 to the 4 newtons. The answer is, oh, I should round it up, 1.4. 1.4 times 10 to the 4, the answer is C. All right, that's how you do 27. Let's do 28. The accompanying diagram shows a 10 kilogram mass held at rest on a frictionless 30-degree incline by force F. What's the approximate magnitude of force F? So, 28, it's held at rest. That means it's not accelerating. That means everything's in equilibrium, and that force F is being canceled out. So let's cancel that force F out. 30 degrees, a 10 kg mass, 10 kg, and F is going to be canceled out by something. So it's being canceled out. Really what's being canceled out by is with the force of gravity. Whoa, that's too big of an arrow. Force of gravity parallel. The force of gravity parallel is this component of gravity that's going parallel down the incline. So to get the force of gravity parallel, what you're going to do is take the force of gravity, which we saw earlier, times the sine of the angle. Now we don't have the force of gravity. We have its mass. We have its mass. Not the same as the force of gravity. This is not Fg. 10 kilograms is the mass, not Fg. I'm writing that because many of you use them interchangeably. They are not the same thing. So if you want to get what Fg was, the force of gravity parallel is equal to Fg, or mass, times gravity, times the sine of theta. Now if we substitute in some numbers, the force of gravity parallel is equal to the mass, 10 kg, times gravity, 9.8 meters per second squared, times the sine of 30 degrees. 10 kg times 9.8 is 98 newtons, times the sine of 30, which is 0.5. That gives us a force of gravity parallel of 49 newtons. 49 newtons, the answer is B. (29). A book weighing 20 newtons. Oh, you know what? I totally forgot. We need to do springs. Just came to my mind. It's okay. Deal with energy. A book weighing 20 newtons slides at a constant velocity down a ramp, inclined at 30 degrees to the horizontal as shown in the accompanying diagram. What is the force friction between the book and the ramp? Okay, well, super helpful again to draw these things out and make your free body diagram. Here's a book. It's 20 newtons, which means its weight, oh man, I can't draw a straight arrow down. Its weight is 20 newtons. Force of gravity is 20 newtons. So you're looking for the force of friction between the book and the ramp. Well, force friction is equal to mu times normal force. Unfortunately, it did not give us anything about mu. So this equation is completely useless to us right now. How are we going to get the force of friction, you might ask? Well, it's at a constant velocity. More key terms. Which means that the part of gravity that's going to make this thing slide down is canceled out by, guess what? Force. Friction. The force that's going to resist the movement of this thing. Force of gravity parallel is equal to the force friction. So, to get the force of gravity parallel, just like you saw earlier, you're going to take the force of gravity times the sine of theta. And the force of gravity they gave us. Force of gravity is 20 newtons. The sine of 30 degrees is 0.5. So the answer is 10 newtons. We're going to go 10 newtons down the incline. And to cancel that out, force friction is going to be 10 newtons up the incline. Your answer is 10 newtons up the ramp. A. Now you can, normally you'd want to use mu and the normal force, but you don't have to. If you make your free body diagram, you can kind of analyze what's going on and arrive at the answer. 30. 12 kilogram cart is moving at a speed of 0.25 meters per second. After the speed of the cart is tripled, the inertia of the cart will be what? So this is Newton's first law. Basically, object in motion stays in motion, and that has to do with the object's mass. Its ability to resist changes to its motion is called inertia, and that is directly proportional to its mass. So inertia is essentially the same as mass. Did you change the mass of the cart? No. You changed the speed of the cart. So since the mass is unchanged, its inertia is unchanged. The answer is A. 31. Surface of planet X, a body with a mass of 10 kilograms weighs 40 newtons. The magnitude of the acceleration due to gravity on the surface of planet X is what? 31. Gravity is equal to the force of gravity divided by mass. You have gravity, 40 newtons. You have mass, 10 kg. So the acceleration due to gravity is 4 meters per second squared. Did I miss something? Oh, D. I couldn't find the choice. D. Okay. Let's do 32. Magnitude, oh my gosh. The magnitude of gravitational field strength near the Earth's surface is represented by what? Now, gravitational field strength might be a term that's unfamiliar to you. You've been using it the entire, last 2 months. Gravity, G. G is the acceleration due to gravity, or gravitational field strength. Let's go back to our question. The magnitude of the gravitational field strength near the Earth's surface is represented by what? Well, G is gravitational field strength. G is the force of gravity divided by mass. A. 32 is A, because G is the gravitational field strength. And G is equal to the force of gravity divided by mass. So A. There you go. Done. 33. Which graph represents the relationship between the magnitude of the gravitational force, Fg, and the two masses, and the distance r between the centers of the masses? Okay. What we're going to do is we're going to take this equation for the force of gravity, the universal gravitational constant, mass 1, mass 2, over r squared. We're going to look at the axes of the graph. So here you have an axis, the y-axis being Fg, and the x-axis being r. Now substitute. Fg is the y-axis, so put a y there. Everything else, g, m1, m2, they're constants. I'm just going to make them all 1 to make my life simple. R is the x-axis, so I'm going to put x in the denominator, and r is being squared, so we're going to do x squared. If you don't know what this looks like, put it into your calculator. Y equals 1 over x squared. Graph it. And you get something that looks like that. It looks like this. Oops, that's terrible. Something like that. The answer is D. Hopefully you can recognize these just from your experience in math class. And if you can't, I just showed you how you can always get this correct. Punch into your calculator. 34. On a small planet, an astronaut uses a vertical force of 175 newtons to lift a 87.5 kilogram boulder at a constant velocity to a height of 0.35 meters above the planet's surface. What's the magnitude of the gravitational field strength on the surface of the planet? Whoa, that's a lot of stuff. Okay. So, the height of the boulder doesn't matter. Constant velocity, I suppose, matters. So since it's going at a constant velocity, that means is that the vertical force is equal to the gravitational force. So the vertical force up 175 newtons is equal to the force of gravity down, G, is equal to 175 newtons. Now since you have the force of gravity, and also since you have the mass of the boulder, you can take this equation, the acceleration of gravity, or gravitational field strength, G, is equal to the force of gravity over mass, which is going to be 175 newtons, over the mass of the boulder, which is 87.5 kilograms. And that gives you 175 divided by 87.5. 2 newtons per kilogram. The unit for gravitational field strength. The answer is B. 35. An electron in a magnetic field travels at a constant speed in a circular path represented in the diagram, which represents the direction of the net force acting on the electron when it's at point A. So centripetal motion. So here's a circle. Oh, come on. Circle. There we go. Here's an electron. Let's make it pretty. It's pink. It's moving this way. Right? So just to kind of refresh, velocity is tangent. That's velocity. We don't care about velocity. We're looking for the net force. The centripetal force is pointing towards the middle. Centripetal force, in this case, it's the net force because there's no other force acting on it. Also, the centripetal acceleration. So which of these arrows is pointing to the left, which would mean the electron is pointing towards the middle? The answer is C. 35 is C. 36. Paste your answers to the following question and the information below. A go-kart travels around a flat horizontal circular track with a radius of 25 meters. The mass of the go-kart with the rider is at 200 kilograms. The magnitude of the maximum centripetal force exerted by the track on the go-kart is 1,200 newtons. What's the maximum speed that the 200 kilogram go-kart can travel without sliding off the track? Okay. So. Let's see. We have the mass of the go-kart, the rider, which is important. And the radius, we have the newtons. Oh, okay. I was going to say you need to find the force friction, but you don't because of how they phrased it here. The magnitude of the maximum centripetal force is 1,200 newtons. So the maximum centripetal force, so centripetal force can't go more than 1,200 newtons. Right? It can't be more than that. So you know the centripetal force is equal to mass times the acceleration, right? And that can't be more than 1,200 newtons. And we know that the centripetal acceleration is equal to velocity squared over the radius, which that can't be more than 1,200 newtons. So if we substitute our values, we have a 200 kilogram cart as the mass. We have a velocity of, we're looking for the velocity. That's right. Haha. And the radius is 25 meters. That can't be greater than 1,200 newtons. Now to get v squared by itself, divide by 200 kilograms, multiply by 25 meters. Divide by 200 kilograms. Wow, that's strange. 200 kilograms, multiply by 25 meters. If you do that on both sides, by 200 kg, multiply by 25 meters. 200 kgs cancel out, 25 meters cancel out. You're given v squared is going to be less than 1,200 newtons divided by 200 kilograms times 25 meters. Take the square root of both sides to get v. V is equal to 1,200 divided by 200 is 6. 6 times 25 is, for a second, squared. 6 times 25 is, why am I blanking on this? 150. 150 meters squared per second squared. And the square root of 150. 150. Oops. And I did this wrong. Square root of 150 gives us 12. 12 meters per second. The answer is B. 12 meters per second. Okay. Now we're on 37. Okay, this is B. 37. A centripetal force Fc acts on a car going around a curve. If the speed of the car is twice as great, the magnitude of the centripetal force necessary to keep the car moving in the same path would be what? So, centripetal force is equal to mass times acceleration, which is equal to mass times the velocity squared over the radius. And if you're going to basically, double the velocity? Double the speed. So you're going to do twice the speed. You're going to distribute the square. 2 squared is going to be 4. So that's going to be 4 v over r, which means you're going to have 4 times the centripetal force to keep you on the track. The answer is D. 38. The gravitational forces Fg between the satellite and the Earth is what? So, the Earth is going to pull the satellite, or the Earth is going to be pulled towards the satellite. The satellite is going to be pulled towards the Earth. And the only one showing you that is C. C shows you basically the flipped version of this. The satellite is getting pulled down towards the Earth. Oh my god. And the Earth is getting pulled up towards the satellite. Yeah, A showing you the satellite going down and the Earth going down doesn't make too much sense. B shows you the satellite moving away from the Earth and the Earth moving away from the satellite. That's not how gravity works. D shows you the satellite moving away from the Earth and the Earth moving towards the satellite, going up. Again, kind of weird. It's like the Earth is chasing the satellite. Not how gravity works. The answer is C. 39. The diagram shows 2 bowling balls, A and B, having a mass of 7 kilograms, placed 2 meters apart. What's the magnitude of the gravitational force exerted by ball A on ball B? So you're going to use the force of gravity equation with the universal gravitational constant times m1 times m2 over r squared. Substitute in some values. 6.67 newtons times meters squared over kilograms squared times the masses of the bowling balls, 7 kilograms. And there's 2 of them multiplying each other, so I'm going to do 7 kilograms squared over 2 meters. That's also going to be squared. Punch all this into a calculator. I'm going to do 6.67 e to the, I forgot to do 10 to the negative 11. I can't believe I forgot the exponent. I would have lost a point on a test. Can't forget that. Times 49, because 7 times 7 is 49. Divided by 4, because 2 squared is 4. And you get an answer of 8.17 times 10 to the negative 10 newtons. Which is a really small number, but I mean, we're talking about the gravity between bowling balls, so I mean, also going to be very small. The answer is D. Oh, no, I'm sorry, that's not D, jeez. C. There we go. C. Last question. Oh, second to last question. An astronaut travels from the surface of the Earth to a position 4 times as far away from the center of the Earth. The astronaut's mass decreases, mass remains the same, weight increases, weight remains the same. Okay, so just to kind of recap. If you're here on the Earth and you go 4 times as far away from the center of the Earth, so now if you're like 4r, basically you're going to take the force of gravity equation, something like this, and you're going to go 4r squared. Now what's going to end up happening is 4 squared is 16. The force of gravity is 1/16 of what it was on the Earth. But that means the choice is not listed. Your weight drops by 1/16. Your weight does not increase, nor does your weight remain the same. However, let's take a look at our mass. Your mass has not changed. The matter, the protons and neutrons and electrons, the stuff you are made of has not changed. Your mass remains the same. Mass is unchanged. Mass is unchanged. So the answer must be B. And that's for 40. Last question, 41. 400 Newton girl standing on a dock exerts a force of 100 newtons on a 1000 Newton sailboat as she pushes it away from the dock. How much force does the sailboat exert on the girl? Again, Newton's third law. Every action has an equal and opposite reaction. If you're going to push the boat, if you exert a force of 100 newtons. So just to kind of recap, there's a lot of Newton words being dropped. There's a girl. Here's a girl. She weighs 400 newtons. That's the force of gravity of the girl. And here's a boat. The boat weighs 1000 newtons. Now, if she pushes the boat, she's going to push with 100 newtons. The boat's going to push back with 100 newtons. Newton's third law, every action has an equal and opposite reaction. The answer is B. Push with 100 newtons. Pushes back with 100 newtons. Okay, that's a rundown of all of the answers and how to do all of these questions on the review sheet. I wish you luck. I know it's very late. Maybe you have time to look at this, maybe you do not. Maybe check it out on the bus ride or trip to school. Take care. See you tomorrow.